Welcome. For the first day here, we're going to be looking at, first problem is simplifying expressions, and the next two are solving equations and writing the solutions. Now, some of the ways they like to test on the starter test is, besides multiple choice, they've got multiple drag and drop number options like we see for problem number 1. They'll also have just inputting a simple x equals and you type in the number, or they'll have some where you have a multiple choice, which are the ones that we're most familiar with that format. So taking a look at our very first problem, we see that it asks us to write a simplified expression. Now, one of the things we've taught is that when you're trying to find something that is equivalent, that we can put it in a calculator, right? And put y equals and put it in. Now, with a problem like this, though, we are unable to be able to say, we'd have to mix and rearrange all these different options to try to plug those in the calculator, and that would just take far too long and not be a very easy task to be able to complete. So these are really not difficult problems. What they have to do is that we are going to isolate each type of variable with its coefficients. So here, all of the ones that have p squared, we are going to take a look at those first. So here we see a p squared, right? Now, p squared is different than p, which is different than just no variable. So here we do not see any p squareds. Oh, and here's one here, right? So what we're going to do is to simplify that, we're going to not worry about everything between them, but I have 8p squared minus 6p squared. So that's going to leave us with just a simple equation of 8 minus 6, which equals 2. So for our first one, I would want to say, okay, great. I can go ahead and take my 2, drag it in. Now, the next thing I'm going to do is take a look at, what about, because I'm looking at just the p. So we're going to just look at now what we have here. Now, since we're distributing, we have a number outside and inside. This could be a place also to use your calculator, but we're just going to look at the p term there, and there's nothing else. So if I wanted to say, what do I do for this if I was going to use a calculator? Because I don't know what, I can do here with negative 1/5 30p. Well, if we just type almost the same thing, we're just going to find out what the number would be, right? So what I'm going to do is show you on the Desmos calculator, if I was to take, I have the negative 1/5, and then I'm just going to put the parentheses, and since we had 30p, we're just going to put 30. If you notice, I don't have to do anything different other than set it up the exact same way that I saw it. And I get negative 6. So I can come back here and now take in negative 6. And then finally, these are going to be, the last one is our just regular numbers, right? Integers only, no variables with it. So if I'm going to take a look at my problem again, I'm going to go back and say, all right, this one, there's nothing there, but here I have the same thing where I have negative 1/5, but not the 30p anymore, but I've got minus 15. And then finally, I've got a minus a negative 9. So again, I still need to include everything between them, right? So I'm going to go ahead and retype this into my calculator the same way. I have negative 1/5. Then I go to my parentheses and I have negative 15. Minus a negative 9. So if I go back to my calculator here, and I say, I need to get my calculator, and I say, all right, again, we have negative 1/5, and then we bring over the minus 15, I gotta put that over, minus 15, minus a negative 9. So if you notice, I can just type in everything that I had when I was simplifying that expression, and I get 12. So I can drag that over and check my answer. We got it. All right, moving on to the second one. Now, when we are looking at solving equations, this, especially when we see that we have a variable on both sides, meaning that I have an equal sign in the middle, but I have my x's on the right and left. So on these problems, we like to say this is our y equals left side, y equals right side. Now, if you've been practicing and attending our sessions, you're familiar with this method. And we can also show you how we can solve this, kind of the traditional way, and I've got that outlined in our Solutions tab here that we'll look at in one moment. But let's first take a look at this with the calculator. So what I mean by y equals left side, y equals right side, I can solve my x by going over here and taking everything on this left side, which is going to be, let's see if we can copy and paste that over. We can. So I'm going to put in y equals, I guess on this one, if I just had my variable, I wouldn't need that, but y equals minus 3x minus 5x plus 6. That was the left side of the equation. Then I'm going to go and do the same thing with the right side. Now, normally on the STAR test, you would have the Desmos calculator above, like popped out above the problem so that you wouldn't have to switch tabs, so you would just be able to type it in. Now, when I do put y equals left and y equals right, I'm going to get, what I see here is that two different lines will be drawn. Now, my goal is to find out where they intersect, because that is where the x's are equal, right? What we did was we set up the left side equal to the right side, so therefore my solution is going to be where those intersect. And as you see right here, we have negative 5.5. So we go back and we put negative 5.5, and we check our answer, and there we go. So easy to use the calculator on that, right? Saves us some time than going and solving that the old-fashioned way, which we'll look at. But problem 3, we're going to do the same thing. So here we've got a multiple choice problem, but I can go ahead and take my left side in my calculator. I'll put y equals my 0.6, 12x plus 18. Then I'm going to take my right side. Same thing here. I'm going to put in y equals. And I'm again going to look for the intersection. Now, the great thing about the Desmos calculator, now if I click kind of close to it, it's not going to pop anything out of me. But it'll have a little gray dot at places that could be important, like the intercepts, like the x-intercept and y-intercepts will do that, but also where they intersect, right? So down here where the two lines intersect, I don't have to be super accurate in clicking it, because it'll automatically slide it to the closest intersecting point, which is minus 3. So if I go back here, I can see negative 3, and I get that correct. So taking a look at our Solutions tab, though, what we can do is look at how would we do this if we were to just have a pen and paper without the calculator. That way, maybe if we see both, you can remember the steps and what we're really trying to accomplish, which makes using the calculator much easier. So on our first problem, when we're simplifying the expression, again, we are going to, now this one we're looking at, well, what if we distributed first our 1/5 into the parentheses, and that way we have 1/5 of the 30, which is 6p, and 1/5 of the negative 15, which was minus 3. This way we can already have that set up, and we can then distribute our negative sign, the negative, into both of the 6p squared and minus 9, which would then change it to negative 6p squared and positive 9. And then we can rewrite that full expression. 8p squared minus 6p plus 3 minus 6p squared plus 9. Now we don't have any of the parentheses to worry about, any distributing, and we can just focus on combining the like terms. So the p squared terms, 8p squared minus 6p squared equals 2p squared. The p terms, negative 6p will stay as it is. And the constants, we have 3 plus 9, which will equal 12. Taking a look at our second problem, what we typically would want to do on this is move all of the x's to the left and everything that's not an x to the right. So here, if we wanted to distribute, first we have our negative 3x minus 5x minus 6, since it was in parentheses. And then that's going to be equal to negative 2 times 2x minus 8. Now if we simplify that left side, we're going to then distribute to the right. So the left side we have negative 3x minus 5x is negative 8x minus 6. And the right side we have now negative 2 times 2 is negative 4. Negative 2 times the negative 8 is positive 16. Then we can, again, look to add 4x to both sides because I want to move my x's to the left. I have x's on the left and right, so we need to do what we call the inverse operation. If it's a negative 4x, we need to add 4x. So if we do that, they'll cancel each other out. But on the left side, the negative 8x plus 4x will bring us now right 4 on the number line to negative 4x. So we have to rewrite this now to negative 4x minus 6 equals 16. Again, we need to move everything to the right side that's not an x. So we're going to add 6 to both sides to get negative 4x equals 22. And then the last step we always do here is to get x by itself. We, again, inverse operation. It's saying negative 4 times x, so we need to divide both sides by the negative 4. Because negative 4 divided by negative 4 cancels out if they're being multiplied next to the x. So here, on the right side, 22 divided by the negative 4 is where we get our negative 5.5. For the problem 3, you're going to follow those same steps. We would distribute on the left, distribute on the right. We'd subtract the 1.2x from both sides so that we move all of our x's to the left. Subtract 10.8 from both sides so that we get our non-variables, right? Just our regular integers on the right. And we end up with 6x equals negative 18. And the last step, because 6 is positive, we would divide it by a positive 6. And that way, x is by itself, and the negative 18 divided by a positive 6 will stay negative at negative 3.